Okay, in the last video clip, we have mentioned something about the change of state. What it takes for the ice to become water, it also absorbs energy. So, about the energy level of an object is not only the temperature that matters. The change of state also involves energy, and that energy involving in the change of state is called the latent heat, 潛熱. The energy taken or given out when the state become another. So for part 1, by the way, this notes is the PDF of this notes is also uploaded to the Google Classroom. You can download it and follow along. It will help you when you do the revision for examination. Okay. Question 1. Matter exists in 3 states. So some of you might think, oh, I see, ice, water, and steam. This is the 3 states, right? It is for water, but that is not the correct terms for all the material. Actually, the official term of the 3 states is solid, liquid, and gas. For example, if you have a piece of metal, you heat it up to like 1000 degrees Celsius, very, very hot, it will melt and become liquid metal. And for nitrogen or oxygen in the atmosphere, if you cool it down to like negative 200 degrees Celsius, they will become liquefied gas. 液態氧、液態氮, they are liquefied. Okay, so these are the official term for the 3 states: solid, liquid, and gas. And there are yet many vocabularies involving how to describe the change of state. So first of all, familiar ourselves with the 3 states of water, which is ice, water, and steam. And the temperature at which the change of state happen, we are quite familiar. Melting point and freezing point is 0 degrees Celsius. Boiling point and condensation point is 100 degrees Celsius. Then why do we have 2 names for one temperature? Actually, melting means from solid to liquid, and freezing means from liquid back to solid. Okay, and this process, the name has also a professional version. You might think melting is common in daily life. However, in professional terms of physics, fusion is the word we use to describe a solid become liquid. And liquid becomes solid, it is solidification. Become solid, solidify, and the name is solidification. It means the process of freezing. The same happens for boiling, become gas, become vapor. You know, steam can also be called water vapor, 水蒸氣, okay? So, vaporization is the word for from liquid to gas. I know there is quite a lot of word here, but bear with me. The last one is more common. Condensation, 凝結. It's like when you have a glass pane of you go to convenience store, 7-Eleven, the glass pane, because the air conditioning, this is very cold, and then the gas molecule and droplet will condense 凝結 on the glass, and it become the water droplet. That is the condensation happening. Okay, so have a look at these words again. There are chances that they will be asked and used in some questions, so you have to know when you see them. And then number 4, when a substance changes its state, it either absorbs energy or release energy. The question is, when does it do absorption? When does it release energy? And you have to think about it. Do you think water becomes steam, absorb or release energy? It absorbs energy, but how do we know for sure. For example, if you have a pan of water, you want it to become steam, you have to boil it, right? You have to provide fire or energy to it so that it become steam. And how do we know steam release energy to become water? If you see if something is boiling and the steam is coming out, you unintentionally touch the steam, you get burned, get hot very intensely. And then this process is because the steam is, of course, firstly, it is at very high temperature, and the temperature change is what we learned in chapter 2. However, a more damaging process is the steam becoming water on your hand. And then at this stage, it is releasing even more energy so that you get hurt very severely. Okay, so from water to steam, it absorb energy, absorb latent heat. Oh, you don't have to draw it like I do because it is actually shown here, but I just write it out, okay? And then from steam to water, it release latent heat. So in this picture, you would know the right hand side is having a higher energy level. In the same manner, ice absorbs energy from the environment to melt. And we have to use a refrigerator to deliberately take away the energy so that the water can become ice again. So water become ice, it has to release some of its energy. And ice become water, they absorb latent heat. Oh, sorry. And if we take water away, the general procedure is like this. On the left hand side, lower energy. On the right hand side, high energy level. So absorb to become the right hand side, and when it becomes the left hand side, it releases energy. Okay, so now we have learned that we should be able to fill in this blank. A substance absorbs latent heat of fusion during fusion. Of course it does. And release latent heat of fusion during solidification. Oops, wrong place. Here, latent heat of fusion is one term. And it is also referring to latent heat of fusion, because the latent heat required from solid to liquid and from liquid to solid is the same. And then next sentence, a substance absorbs latent heat of vaporization and release it. During, okay, it absorbs, so it gain latent heat. It is from liquid to gas, so it's vaporization. And then on the other hand, when it goes back to liquid, it will release the energy. So this is condensation. and we call the latent heat, we use L to symbolize. And this part, because latent heat of fusion and latent heat of vaporization, we use L small f to represent this part between solid and liquid. And we use LV to represent vaporization part, because the energy needed is different. So now we have the terms we can use to describe the situation. Let's have a look here. This curve is called heating curve. It sees the change of state from solid to gas. So this region, the thing is in solid form, and then since it is being heated up, the temperature will increase and climb up. And at this in this yellow part, it is still continuously absorbing energy, but the energy is not shown in the temperature change. Rather, we would call this part of energy the latent heat of fusion. It is absorbing the latent heat of fusion to change from solid to liquid. And then when they all become liquid again, the temperature once again climb up until it reaches the point where it is exactly at the boiling point. And then all the energy absorbed in this period, they are the latent heat of vaporization. And the process here is boiling. The process here is melting. In the state of changing, in the process of changing state, it is a mixture, okay? And finally, they all become gas and the temperature rise again. So here, on the opposite side, the gas become liquid, and then the liquid becomes solid. And the same thing happens, but the name is different. Oops. For the green part, this is between the gas and liquid. So the latent heat of vaporization is here. If I change this to also using green, darker green, oh, it is the darkest. Okay, and then this part is the latent heat of fusion, because it is between the liquid and solid. And then I should copy this part and put it here. Change the color. Oh, don't waste time, Mr. Wong. Don't waste time. Okay. Here it is condensed. Here it is freezing. And during the process, on the right hand side, it releases energy. So you are required to be able to describe this process in words. For example, from this time to this time, the solid increased the temperature, and from T1 to T2, it is absorbing latent heat of fusion to melt. It is a mixture, okay, something like that. You have to be able to describe. And if we have a look at this level, actually this is the boiling point. This is the melting point. That is how we understand this type of graph, okay? And one more term, we'll maybe next time, specific latent heat. Oops. Maybe we will cover the bottom part next time. Okay, for this part, the coming homework, this part will do. I know there has been quite a lot of vocabulary this time. I hope you can start to recognize them. They will be useful in the questions. Thank you.